This video's toolkit includes essential constants like the Coulomb constant, elementary charge, and the mass of electrons and protons. Remember that the sign of the charge matters for calculations. The equations needed are for force, electric field, potential energy, electric potential, and uniform field. Let's move to level 2, the electric field. Problem 3 asks for the magnitude and direction of the electric field experienced by a 20 micro-Coulomb charge with an upward force of 27 millinewtons. Problem 4 asks for the electric field magnitude exactly midway between two positive 20 micro-Coulomb particles separated by 20.0 centimeters. Pause the video to solve these problems. For solution 3, using the formula E equals F over Q, the calculation results in an electric field of 2700 newtons per coulomb, directed upward. Note that the electric field is in the same direction as the force, upwards, because the charge is positive. For a negative point charge, the electric field vector will point in the direction opposite the force. Solution 4 uses vector superposition. Notice that the electric field from positive source charge points away from the charge. Therefore, the electric field from the charge to the right points to the left, and the electric field from the charge to the left points to the right. Since the charges and distances are identical, the electric fields cancel out at the midpoint, resulting in a net electric field of 0 newtons per coulomb.